Hello and welcome to the asynchronous lessons to be done during Thanksgiving week. During these, I would encourage you to pause the recording from time to time to attempt the problems. As with this slide, good idea to take a look at it, pause it, and then check your work based on what has gone over. With that being said, let's go ahead and get started. So, for this presentation, we're going to be talking about power series, meaning series involving x to the nth power. Beyond that, just about anything can go into power series. So to begin with, let's expand the series, the sum n equals 0 to infinity of x to the n over n factorial. Expanding this results in, first of all, x to the 0 over 0 factorial, then x to the first over 1 factorial, and going on up, where the fifth term is x to the fourth over 4 factorial. Noting that 0 factorial is 1, and the 1 factorial is also 1, and using a calculator for the other values, we get the series 1 plus x squared over 2 plus x cubed over 6 plus x to the fourth over 24. Now, another thing about power series that we will be interested in is determining which x values they converge for. So in this case, because we have n factorial involved, we want to use the ratio test. So for the ratio test, we take the limit as n approaches infinity of the n plus 1th term over the nth term. Doing that, we get x to the n plus 1 over n plus 1 factorial over x to the n over n factorial. That then becomes x to the n plus 1 times n factorial over x to the n times n plus 1 factorial. Simplifying gives x over n plus 1. Because n goes to infinity, this means this series converges for all real numbers, since the limit will be 0 for every real number. Next, I want to go over a somewhat common power series to come across, and that is the sum n equals 0 to infinity, negative 1 to the n, x to the 2n over 2n factorial. This series actually has been used by your calculator more likely than not, as your calculator uses it as a way of calculating a particular function. So, writing out the first 5 terms gives 1 for the first term, because x to the 0 is 1, negative 1 to the 0 is 1, and 0 factorial is 1. Then minus x squared over 2 plus x to the fourth over 24, noting that 4 factorial is 24, minus x to the sixth over 720, again 6 factorial is 720, plus x to the eighth over 40,320, as that is equal to 8 factorial. The series does go on infinitely, and you may notice that first of all, it repeats between minus and plus, making it an alternating series. Also, the size of the denominator ends up making this series converge for all real numbers. Now, go ahead and on Desmos, sketch the series below. If on Desmos you write SUM, it will give you the sum notation and you can fill these in. As you sketch these, look at what function they begin to form. If you have not done so already, pause the recording and sketch those. If you already have, what you should see is that these start to form a wave, and specifically these start to form the wave of cosine. And as it turns out, this infinite series here is the series for cosine. Going back to a general definition, a power series is any series that can be written as a sum n equals 0 to infinity of the nth coefficient times x to the n. So in this case, c with subscript n is a number where we can have a rule in terms of n, Although, what rule we have, anything can be the case. Another type of power series is to do the same thing, but to have x minus a in parentheses raised to the n. This would be considered to be a power series centered at x equals a, whereas the top one is centered at x equals 0. We talked about the convergence of series, and if you recall, a series converges when it is equal to an exact number and not either infinity or something that forever oscillates. As it turns out, power series will always converge for some values of x. The way to think of this is, remember, if we have x minus a raised to the nth power and x is equal to a, then we are adding 0 repeatedly. The only exception is when it's raised to the 0 power and we choose to define x minus a to the 0 power as always being 1. So if x is equal to a, then it's just equal to the first coefficient. On the other hand, some series will converge for all real numbers. That's the case for the power series for cosine, where you can use that series to find cosine for any value of x. Please note it must be in radians. On the other hand, then there's a third case, and that is some power series only converge for a radius, or in other words, how far away from A can we be in order for the series to still converge. So again, radius of convergence is indicating how far inputs can be away from the number A that's subtracted from X and still result in the series converging. To determine the radius of convergence, we will use tests we used to prove series converge from before. The difference is now that after we use these tests, or after we identify a type of series, we will then either solve for x in the case where some of the time it does diverge, or we will determine that x can be any number when it will always converge regardless of the value of x, or that the radius is 0 if no matter what value we put in for x, the series diverges. Looking at the first series, we see the sum from n equals 0 to infinity of x to the n over 5 to the n. This can be rewritten as the sum n equals 0 to infinity of parentheses x over 5 parentheses to the n. This is a geometric series. If you recall, for geometric series, a geometric series will converge if the number raised to a power is less than 1, or that is more specifically, the absolute value is less than 1. That means if x is between -5 and 5, the inside will have an absolute value that's less than 1. Because we can go 5 to each side of x, that gives us a radius of convergence of 5. Now, let's take a look at the next series. So the next series is a little bit more complicated, as we have the sum n equals 0 to infinity, 3 to the n times x to the n over n factorial. Given that there's an n factorial, we'll use the ratio test. Setting up the ratio test, we get parentheses 3x to the n plus 1 over n plus 1 factorial over 3x to the n over n factorial. Note that 3 to the n x to the n is the same as parentheses 3x to the n, which is the reason for the setup. If we then go ahead and simplify this, we end up getting 3x over n plus 1. So the limit as n approaches infinity of 3x over n plus 1. This comes out to the limit of 3 times some real number over infinity. This is always 0, no matter what number we put in. Therefore, the series converges for all real numbers, and we say that the radius of convergence is infinity. Thank you for watching this. If you have any questions, please email me. Have a good day.